right, we're going to do the two lens diagrams at the bottom, and we're going to start with concave lens diagram, okay? I need a ruler first. All right, I'm going to start by making the origin. Yeah, it is pretty neat. And then I'm going to tip it and make a perpendicular line. This is supposed to represent the middle of my lens. We keep using, I'll show you in a second. It's a perpendicular line representing the middle of my lens. And we are going to do a concave lens first. So a concave lens looks like this. I'm going to make it cave inward, concave, like that. So far, so good. And I'm also going to add two foci. They have to be equal distant from the lens. So let me show you how that's done. All right, I'm going to measure one about, let's put one about, let's use inches. 3? That's a little far. Let's put one at 1 right there. I'm going to go to the other side and put one there as well. Okay, and then finally I need an object that I'm going to be studying the light from. So a penguin. Yeah, there's a penguin. Okay, that's enough of that. All right, there's our penguin. It's bow tie. All right. Moving on. So, in this class, I'm only going to draw 2 lines of light, 2 rays of light. There are 3 to do it completely. So the first ray of light I'm going to show you is going to be the horizontal. It basically follows parallel to the origin. I'm going to draw it in red, and it's going to go directly to the center of the lens. When it hits the center of the lens, it's going to connect to the first focus like this. So what a concave lens does, that's kind of interesting, is it reflects a little bit of the light. So some of the light is reflected backward. I'm going to draw that as a dashed line. And some of the light is refracted through. This light is refracted through, and this light is reflected backward. A little bit of both. For the next ray of light, I am going to, and by the way, here's a little trick for you. The easiest one, the easiest ray of light through any lens diagram is right through the center of the lens. So I'm going to start at the top of the penguin's hat and go right through the center of my lens, and that's all it is there is to it. It just goes through. It's very easy to remember that one. Okie doke. No. There's another ray of light which would go through the second focus, or at least toward it, and I've chosen not to draw it. If you'd like me to draw it, we'll draw it after we've created our image. Our image is right here at the intersection. Let's see. My penguin's kind of falling apart here. Let me put them together. What's all this business? I'm going to group it all together, grouping, group. Okay, now I can move my penguin. I'm going to clone him or her. I can't tell. If it's a boy, then it's got an egg underneath of its belly. All right, there we go. There. So you will notice that the image is a lot smaller. It's upright, and it's on the same side of the lens as its object. So there are three descriptors for this. 1, 2, 3. Magnification, smaller. Upright or upside down? Upright. And lenses are opposite of mirrors. So if the image is on the same side of a lens as its object, it's imaginary. Okay, this is now a complete lens diagram. That's all the information you need. And like I said earlier, I'm going to show you the third line. The third line, you don't need to make it, but if you wanted to make it, and you will in probably physics, it starts off by heading toward the opposite focus. Yours is not going to work as well as mine because I didn't measure your foci. I just eyeballed them. So please don't try this. It's going to mess up your drawing. It basically goes toward the focus, and when it strikes the center, it's going to do a little bit of reflection and a little bit of refraction. The refracted beam of light goes straight, horizontal, and the reflected beam of light, again, makes a third intersection. They all are supposed to intersect at the same point. Yes, ma'am? That's a fantastic question. And first of all, you said, why is there a focus on the other side of the lens if nothing goes through it? Light travels through lens. So there is light traveling through lens. And the reason that there's a focus on the other side is you kind of have to get back to the definition of a focus. The focus here is supposed to represent the center of a circle made by this arc. And there's two arcs. They're not drawn very well, but remember how this is the shape of the lens is? The focus is supposed to be the center of a circle made by the lens. And since the lens has two curves, since this focus has two curves, it has two foci. For a convex lens, there's a side here with a focus, and then there's a side here also with a focus. Optics is a lot of circles, basically. They're in arcs. Does that answer your question? Good. Yes, sir.
I want to say, they could actually also be called ellipses.
I don't believe an ellipse would be a good idea for lens making. I think that you want the curve to be an arc of a circle, not an ellipse. I think if you made an elliptical arc, if you took a section off of an ellipse and tried to make a lens out of it, light would behave differently depending on where it struck it. So it wouldn't behave uniformly. But that's just me saying that. I don't know for sure. I mean, we could all be pleasantly surprised to find out that there are elliptical lenses. Or I wonder if there's elliptical lenses for treatment of a astigmatism, for example, in your eyeballs.
Why don't you look it up?
Why don't you look it up and come back to us, and I'll throw you some extra credit for that kind of research, because I don't know. Elliptical lenses, write it down, look it up. Yes? Fantastic question. I'll give you a couple of reasons why this is imaginary. The first reason, and this is always useful, lenses are meant to, light is meant to travel through lenses, okay? So it's a little weird that the image of this particular lens is not on the other side of the lens, because that's what's supposed to happen. The second thing is, this image is formed by reflected light. It's not how lenses are not meant to reflect. So it's an image made by dashed lines, okay? So whenever you have an image made of dashed lines, it's going to be imaginary. On my mirrors, I actually had dashed lines behind the mirror because light does not go through mirrors. See, those were the imaginary for mirrors. See, in a mirror, if the image was over here, that'd be imaginary. For a lens, if it's on the same side, it's imaginary. I hope that helps a little bit. Let's do our convex lens. Can your object still be the penguin? I suppose. Here we go. Here's our origin. You already have this sketched out, and your foci are not drawn correctly, so it's not precise on your piece of paper. This is a convex lens. Has two foci. Oop. You know what? I'm going to measure them so that my drawings work. If you don't measure them, then your lines are not exact. I'm going to do it at 2 inches. And 4 inches right here. Okay. There. And you wanted the penguin again? Copy and paste. There. Okay. So we're going to start off with the same horizontal line. Move it to the center of the lens. When it hits the center of the lens, it's going to go through the focus on the other side. Forever. Forever. How do you show a line is traveling forever? Whoop. Arrow is correct. I want to make sure it goes through. True. Arrow is right. Now in this lens, we don't have any reflection going on, so 100%. It seems like 100% of our light is going through. There is a little bit of reflection anytime you cross from air. It's air over here, and it's glass in here. So there's a little bit of reflection, except it's not as part of the diagram. We're going to have a real image. You'll see it doesn't require us to worry about the reflected light. All right, next, I'm going to draw a line right through the middle. That's the easy one. I will also draw the third one at the end, but I want to do the easy one. Right through the center. There we go. It also goes on forever. Does anybody know where the image is going to be? Sir? Correct. Any special things you want to say about it? It is real. Is it like that? Right, we have to flip this penguin upside down. You know what would be funny? You know how I always say puppy? I should make an image of a puppy, and then I'll be like, we have to flip this puppy upside down next time.
Oh, so we can have the puppy. So we can have Dr. Penguin.
Yep. 3 things. Help me out. What are the 3 things that we can say about this? Upside down. Real. And size? I did have to shrink my particular one. Yours, you'd have to make your own judgment. Sometimes it's bigger, sometimes it's smaller based on where the object is compared to the focus. So this one happens to be smaller. Okay, so that's what you have to do for the quiz. Yes, ma'am. Correct. No. The ones that start fire are the ones that create real images. So a convex lens creates a real image and focuses all the light. The third ray of light through this one would look like this. Let me show you. And basically what focusing light does, you know how the sun is warm? Well, what focusing light with a lens does is it basically takes the warm part of the sun Sometimes this works and sometimes it doesn't. And it basically says, okay, we're going to take the warm part of a sun, the area of like, say, if your lens was a foot in diameter. So it would take that area of a circle, a foot in diameter, and put all that heat into a pinpoint. So basically, as soon as you start doing that, and mathematically the point is infinitesimally small, so it has no area. It's basically stacking and overlapping all that energy. It gets hot, really hot. To be honest, you don't actually need a super large surface area for the lens because, like I said, mathematically, if you get the focus just right, you're creating a point which is infinitely small. I'm going to cheat, make this work. But the larger your lens, it helps. It means you can be off adjustment a little bit, and it'll still work plenty fine. So there's your third ray. So any
It also for your prism. Oh, actually, it's a mirror. It really is mirror.
yeah. You want me to show you how this thing creates a fire?
Yes.
All right, let me do this. Let me clone it. Actually, I have an idea. Can I cut and paste the whole thing? I can copy slide. Clone page. Bam. Thank you, ma'am. All right, so let's get rid of, we're going to now, instead of using a penguin or an object, our object is going to be the sun, and we are going to discover that a small fire is born. Delete. Yeah, they're all going away. No. He's fighting back. Yeah. All right. Okay. What's that? Tape? Right there up on my desk. See it? It's in the blue container on the ledge. Higher, higher, next to the clock. There you go. Okay, sunlight comes in. What does this lens do? Sunlight is always coming in horizontal to the origin. That's just the way it works. It's going from so far away that it's a straight line, and it's going to be focused through there. You guys are like perfectionists. You're perfectionists when it comes to me doing things. All right. It doesn't matter where the light comes in. This is how sunlight looks. It's always, I'm going to draw a couple more. I could do it up here.
It's always red.
Yeah, it's sun.
Does that always match?
I can even go beyond the lens. It doesn't matter. All of them are going to go through the focus. So you can imagine that's stacking a lot of energy. It gets really hot. This is what magnifying glasses do, yes. Some glasses. Some glasses are concave. Okay, are there any other questions about the diagrams? It basically acts like a digital straight edge. Okay, something like that. So that's why these create fire. Now, an object which is not the sun is closer, so therefore the difference is an object that's closer sends light that comes off at different angles. The sun sends light which is all horizontal because it's practically an infinite distance away as far as we're concerned. Okay? Any other questions?
But isn't the sun expanding?
Yes, ma'am. Okay, for a mirror, if you want to know real and there's simple rules. Real or imaginary. Mirrors are opposite of lenses. For a mirror, it's real object and image are opposite of each other. Imaginary is object and image, same side. For a lens, it's those flipped around. Yes? You thought what? Holy smokes. Real, oh my goodness, you're absolutely right. That's what I meant the whole time. I was just testing you. Yep. 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 YouTube, I was testing. Anyone watching this, I was testing just to make sure that you saw that. Very good. Thank you, Amanda. Any other questions? Okay. I'm going to stop the video. I think that's all the information we need today.